and welcome to Embedded Internals. This is 5th episode of our series, C System Fundamental series. In this episode, we are going to see arithmetic operators through CPU thinking. Until now, we have learned what are bits, what are memories, what are different data types available, how the promotions happen, what happens when the data types overflows. In this episode, we are going to see how does C actually perform computation. We can say that this episode is actually a bridge between C expression compiler, now the CPU instructions, register change and memory. This is for the bridge. We have C expressions. When we say C expression, how the things are expressed like bits, bytes, hexadecimal, binary format, all these things inside the memory. When there comes the compiler, how compiler actually doing the promotions, how it is detecting the overflow, what are the different data types compiler is seeing, and based on that how the compiler is actually reserving the memory for them. Now how the CPU performing the operation, so CPU instruction, this is where we are. In the coming episode, we will see the register changes and how the memories is being updated. CPU instruction will happen, then the register value will change and the memory will got updated. Let us see what is happening. When we say arithmetic means operator operations like plus, minus, divide, multiply, all these things. When we write x is equal to x plus 5, we are incrementing the x parameter. At this point of time, what machine will do? First thing, it will load the value of x into the memory. Second is it will perform the operation addition, so add 5. Third is store the value back from registers to memory. So load, perform and store. So there it is, operators transforms value through loading, computing, converting and storing. Here it is loading, computing and converting, and here it is we are storing. So these are the multi-step process. So in the arithmetic or in the CPU level, if we say from the memory, load the value into the registers, it is CPU registers. From the register, do the arithmetic operation. Inside CPU we have ALU, arithmetical logic unit, which is the one who is responsible for perform all kind of arithmetic operation, and after the operation give back the value to the register where that value is further stored into the memory for the user. So all these steps are happening. We do a simple perform arithmetic operation. We have different kinds of registers like GPIO, timers, interrupts, various registers. So registers are basically very fast tiny hardware component where all the computations happen. When we are saying in the terms of memory, it is larger and slower. Registers are very fast. So this simple parameter int x is 10 and add x plus 3 or 10 plus 3 13. Inside the assembly, when you will see, you will have all these things. Load first x, move this value to a particular register. X has value 10, it will be moved to R1. Now we have to add 3. So R1 has the value 10, add 3 to it. And then move back or store R1 into memory, or we can say store R1. Let me show you in the terminal what is actually happening. Let us write a simple program. We have int a, some value, let us be 10, and b that has some value 3. Let us have one more variable, c, where we will store the result. So c will simply become a plus b. Let's printf the result. Output is 13 expected. But this is we are not computing the program for addition. We need to see what is actually happening inside. The CPU. So let me show you how this is behaving inside our main. This is the main frame. Let me give a simple introduction to this object dump. So we are disassembling our ELF file, that is a.out. We have init section, PLT sections, PLT got. All these sections has been uh, detailed. I have detailed explanation of all this section in our execution awareness series. To check out that. Let us first move to text segment. There we are starting our code. We are loading the registers, base registers, DX register, SI registers, and all those registers. And then finally we are moving to our main function, calling the main function. So glibc start main. Let us move to our main function, that is 1149 address. 114. Okay. Here it is 1149 main. First thing what is happening inside the stack is push RBP. So it is push the base pointer inside the stack. Copy the base pointer and the stack pointer. This is to allocate the memory for in the stack. Now we have three parameters. So allocate 10. 10 is 0 into A inside our value. So we are storing this at particular location. Then at the base pointer RB, we have stored one more value, that is 3. 10 plus 3, 13. So we are, and after that we have moved this register into the EDX and this register to this. And after moving the registers, we have done the promotions. We are doing the addition operation, DX on AX register, that is 0C. This value plus में minus 08, that is this value. So 10 and 3, 13, and doing the promotion. This is that we are simply storing the value inside our stack. Minus is because stack grows downward. We have allocated this much memory in the stack. So let me show you. It will be like we have allocated this much memory inside the stack. So initially our stack pointer is here. We have to move downward. So when we are allocating A is equal to 10, so taking the 4 byte, so negative of this, then from C, let me show you. See in the terminal, this is C 12 and this is 8. 12 minus 4, that is 8. We are moving 4 downward. Okay. So 4 bytes downward, we have one particular value B where we have stored 3. Then loaded both these registers into copied. 10 is value is copied into one register R1. Suppose B value is copied into other register. Then the arithmetic operation has been performed. So after load, move is happening. Let me show you in the example. So here memory allocated, and then we have assigned the values. Then we have moved those into a particular register DX and AX, and then perform the arithmetic operation, move the memory into the registers. And after performing the operations, we have stored the address C parameter and 4 byte, that is less. 8 minus 4, that is 4. Store the value EX into this. After storing the value, we have just moved our stack pointer, doing the promotion to leave, just returning from the function and calling the printf function with the values to print the statement. So this all is happening inside machine. So this is how the CPU is actually doing the operations, to from loading the base pointer, stack pointer, to do allocating the memory, to moving the register, to allocating the memory to the variables, and then moving the memory into the registers, then performing the operation, loading back the register into the memory, and then doing the operation to of print statements. All this is happening inside the CPU at that time. This is how stack operation is actually performing: load, move, add, store. So next we are going to check addition with overflow remainder and signed char. So char is 1 byte. 1 byte means 0 to 2 to the power 7. That is 128 possible range. 0 to 127. At maximum, if all is 1, we will get 255. Now we are doing one addition operation. So we are moving to 2 to the power 8. So this will become 0, 0, 0, 0, 0, 0, 0, 0, 0. So the value which we will get is from the 8 bits only, or 1 byte range only. This is beyond our 1 byte, and so this will got discarded, and we will get the value 0 because of that overflow. We will say that arithmetics always type rules. Similarly, when we are doing the subtraction, this is in the addition case. When we are doing the subtraction represented by minus sign, like int x is equal to 10, x is equal to x minus 3. Result will be 7. Okay, but what is happening inside the CPU? That is our concept. We are not doing the computations here. It will be load, subtract, I will show you, and then store. Let us see that inside the terminal. A minus B. Okay, let's see what is the output. 7. What is happening inside our object dump? Inside the main function moving. Now this is the operation subtraction. All the parameters are moving. 10 has been moved, this memory allocated, and then they are from memory they are loaded to register, and at the register we are doing the arithmetic operation to subtract the value, and after doing the subtraction we are just loading the back into the memory. So this is what is happening inside the CPU. Similar to addition, only the operation has been changed. When we have some negative remainders, like in that case, when int is equal to x and y will be x minus 20, so the answer will be minus 15. So this is signed arithmetics, and that is also we can do in same format, only the sign bit now come into the picture. Sign bit should be enabled to represent the sign value. To arithmetic operation, addition and subtraction, we have multiplication. Multiplication inside computer, that is represented by this parameter. Int x is 6, y is 7. We can simply do x into 7. This is to represent multiply, or x into 7, that is 6 into 7, whatever the value. So in the multiplication also we will have the same CPU computation operation, that is load. Now the operation will change, that here in this case multiply, and store, load into the memory, memory, from memory to register, register to memory at the case of store. Or assembly format corresponding to multiplication is simply I mul. Multiplication can also overflow in case of larger values. So as arithmetic always the storage limits, we should be very careful when we are dealing with the larger values. Now we have a most misunderstood operator, division operator. When we are doing 7 divided by 2, output is usually 3, not 3.5, because this division operator fraction values get discarded. So we should be very careful. When we need fraction, we need modulus. And we have the float division where we can have the fraction values as well. When we are doing the float division, that is 7.0 divided by 2, in that case float division we will get the value 3.5. So we should be very careful in this case of type, because type is determining the operation. In the case of division, type determines operation. One of the most faced error is divide by zero error, which result in undefined behavior. So similar to all these operations, we have one modulus operation where uh, we return the remainder. In the division operation, remainder get discarded, where in the modulus, division get returned. Like 13 divided by 5, it simply become 3. Modulus is returning the remainder. Where we are using the modulus, we seems that we don't use modulus frequently, but modulus are frequently used when we are doing operation for even and odd deduction. When we are checking for any kind of wrapping, we will use the modulus operator. When we are doing any kind of hashing operation, modulus operator are used. For cycles check, or we can say for any kind of clock arithmetics, like in the case of when x divided by 2 equal to 0, we can say value is even. So modulus operator are frequently used inside our programming. We can do modulus with negative values also, but sometimes sign rule can surprise programmers. So we should be very careful while dealing with the negative values. Standard and compiler behavior need to be checked before performing any kind of operation. Now, we along with these arithmetic operators, we have some urinary operators, that is urinary plus, urinary minus, and all these things. Let us see urinary operator which require only one operand, like plus x, minus x, only one operand. In the case of like x is equal to 10, and for the urinary operation minus of x we are printing. When the highest range is reached, it may overflow. So overflow check should be there for urinary operators as well. Urinary means simply performing operation with one operands. Now let us move to increment and decrement operator. Increment and decrement. Increment plus plus, decrement minus minus. X plus plus, use value then increment, plus plus x, increment then use values. X minus minus, use value then do the decrement. Minus minus x, do the decrement then use the value. This is usually very confusing, and we should be very logical while performing the arithmetic operation and decrement, and multiple operations into a single line we should avoid, because the result may be surprising to us. So one is pre-increment, one is post-increment. So when we are doing this we will call pre-increment, or or this is post-increment. So in the post increment, like post, which is x plus plus, it is like update and return. So we have some value 5, we are doing 5 plus plus, and if we are not printing it, it will return simply 5. In the next statement, when we are using the x value again, then we will convert that value first 6, and then we will do the operation. Like for an example, you have a simple code where you have declared x, which is 5. Now you have done x, you have printed the statement to print x plus plus. Value you will get is 5. When in the case of printing, you will simply do some arithmetic operation, x plus plus, value here is 5, and when you are using the value, like in the next statement you are doing x plus 10, so there the value will become 6, and then you will use add 10 to it, it will become 10. So it is like update and return. When we are reusing it, you will be reusing it with the new value. So most of the time when we are incrementing, decrementing either post or the pre, and then storing the value into the same variable, evaluation complexity will occur, and this can be a dangerous. So we should be very careful while doing this. Like x is equal to x plus plus. Similar to increment and decrement, we have compound assignment. Compound assignment is like x is, so this will become x is equal to x plus 5, x is minus equal to x is equal to x minus 5. Compound assignment, where two operation we are performing at once. We have integer versus floating arithmetics also. When we are doing the float arithmetics, we will get the value after the decimal point as well. So what is when we are doing all the operations like the plus, minus, multiplication, division, modulus, how they all are behaving? Are all they behaving in the same way? Plus and minus are usually fast operation as compared to multiply or divide, where division is usually expensive. Means it takes lots of time, CPU time. How long the CPU takes to perform the arithmetic operations, uh, based on which we will figure out the operator cost. Execution pipeline, where we have particular expression, we will do the promotions if we can, and then the value is getting computed, like in the case of sometime character that is being promoted to integer, and after the computation we will do the conversion and then store the value into the memory. So operators do not act on variables, operators act on values, right, which are produced during evaluation. So this is all in this episode, where we have seen most common operations, ALU operations, including addition, subtraction, multiplication, division, where we are storing, loading, and how the CPU is behaving in all those arithmetic operation values. In the next episode, we are going to see some more operators like comparison operator, logical operator, conditional operators. Stay tuned for same. Thank you.